So let's take some QED process. So, okay. So let's take first process, what we call the electron-electron scattering. So this is a elastic scattering. So I am taking this as an elastic scattering. So what does that mean? So two electrons are coming. So they scatter elastically. So only there is an exchange of momentum. Okay. Clear? So that means the final product is also the electrons. So like this. So I am having electron. Let's say in the momentum state, okay, P1 S plus P minus 2. Let's say P2 R. So S is the spinner. S and R, they are the spin variables. So this is our process. So E minus, okay, again. So it will be P1 prime, let's say S prime, plus E minus 2, P2 prime, R prime. So this is our scattering. Let's write the Feynman diagram corresponding to this very scattering. So it's possible that they are in the, okay, so P1 goes to P1 prime, P2 goes to P2 prime. It's possible that P2 goes to P1 prime. So the exchange of the momentum. Clear? So you are having a direct process and the exchange of the momentum in the final state. Clear? So let's write that. So okay, so let's, since this is a second order process, we know QED at the single vertex it does not exist. Clear? That we are seeing. Okay, we'll see in a moment a process where we are having a single vertex QED, that is in presence of an external static field, some other kind of field. Okay, so the field is, since it is an electromagnetic interaction, you can consider the electromagnetic field here the dynamic field. In a sense, we are quantizing that field. So the field is quantized here, the photon field. Okay, so let me tell you what does that mean. So you are having an electron that comes, okay. So these are the two electrons, okay, in the initial state. So at the vertex, what will happen? So now tell me. So there will be an exchange of a photon. Clear? So let me write. So I am having an exchange of the photon. This electron will go like this thing. This will go like this. Because when you are having two vertices, that means there must exist a propagator. And here, what is the propagator? It has to be a photon propagator. Exchange of a photon. Now okay. So let me tell you what a dynamical field here means. Since we are quantizing the electromagnetic field, okay, so it means electromagnetic field is a dynamic variable, okay. The way you are quantizing the matter field, okay, since it is a Dirac field, so these are the dynamic variables, okay. So an important consequence of that is, let's say electron, it has an electromagnetic field with it, and this electron has an electromagnetic field with it. Clear? So this influences this field, and there is a back reaction of this electron on the other. So in other words, there is a mutual interaction between the two. The way one electron influences the other, it is the same way the other electron influences the first one. Clear? So there is okay. I will give another example where it's not possible, where you can ignore these kind of back reaction effects. Think of Rutherford scattering. Clear? You are having a nucleus, a stationary nucleus. Okay, that creates only the which potential? Coulomb potential. There is no electromagnetic vector potential. Clear? Only the phi is scalar potential is there, and an electron passes by that very nucleus. Clear? Samashaman, you can think only the nucleus exerts force on the electron, and there is no back reaction of electron on what? The nucleus. Samashaman, you are taking nucleus to be heavy. Got it? In such case, the field which describes the exchange of a photon between electron and the nucleus, so that kind of field we will take as a stationary field, static field. Samasha, that is not a dynamic field. Got it? Dynamic field means you are having both action and back reaction effects. Got it? Okay. So let's write what is the, so this is our electron. So it is E minus P1, let's say S, and it's E minus 1. So first electron P1 prime S prime. So I should not write E2, it is E, simply the electron. So this is E minus P2 R, and this is E minus P2 prime r prime. Clear? So now there can be the exchange of the momentum in the final state. Okay, so that means you are having the state of the particle here ps. Clear? It exists in the momentum state ps. So it goes into which state? P prime s prime p1. So it is p1. Okay, so and it's p2 here. Clear? So it may go, this electron after scattering, it may go to this very state like this thing. So I'll be hanging this electron in the initial state. Okay, then the exchange of the photon. So let's try. So this is your E minus P1 S and E minus P2 R. Clear? So it may happen. So you are hanging like this thing. So it is your E minus. What is the momentum on this very state? P2 prime S prime. Okay. So let's write R prime. Whatever. Okay. So then I will be having from this vertex. So it's not the, this means, so there is no cross. Huh? So these lines do not cross. Huh? Okay. So it's E minus P1 prime S prime. Clear? Samajh? So these are the, okay, so now electrons are fermions in nature. Okay, so now what is the total Feynman amplitude? Feynman amplitude will be the sum of the Feynman amplitudes of the two processes. Clear? You got it? Okay, now the point is that how to sum, whether I will put a plus or minus sign here. Now this is a direct process, this is an exchange process. Clear? But here is the exchange of the two fermions in the final state. So when you exchange the fermions, when you interchange the states of the fermions, what will happen? So it will yield a negative change sign. Okay, so that means the total amplitude of this very process. So I can write as amplitude of this very thing minus amplitude of this thing. Samajh aaya? Got it? Okay, so now let's write the Feynman amplitude using the Feynman rules what we have at hand. Okay. So samajh aaya? We'll just write the Feynman amplitude. We'll not calculate any scattering cross section. Okay, so that those are I mean, although those are straightforward calculation, but I mean a lengthy calculation. But the point here is, my aim is here you to show what are the diagrams, possible diagrams, and how you can write the amplitude for that. If you know the amplitude, you can calculate the scattering cross section. Okay, so let's write the amplitude of the first cross. Let's call this as A. Okay, so let's call this as B. Now tell me what is the Feynman amplitude corresponding to the process A. So how you start with? Okay, now tell me what to do. So I have to label, this is a vertex, correct? So what is our QED process? So since these are the electrons, our Lagrangian, that's equal to minus Q. Tell me. So you are having A mu, psi bar, gamma mu, psi. Clear? What is the vertex there? Vertex is equal to minus I Q gamma mu. Clear? So that is equal to, okay, so that's simply I E gamma mu, where E is the charge, minus E is the charge of the electron. Huh? Okay, minus E is charge on electron. Clear? Samajh aaya? Okay, so now what I have to put here? No, sorry, it is minus and it will be minus. So what I have to do? Okay, so it's minus because we have to look at the Hamiltonian. I'm sorry. So the Hamiltonian will be like this thing. So H will be like this thing. It will be simply E. Okay, so it is Hamiltonian is Q times like this thing. From the Hamiltonian, I have to get the interaction Hamiltonian. Okay, so it is minus I. Okay, so what is this very factor? Tell me. So it is IE gamma mu. So let's specify here IE gamma mu. What this will be? IE gamma mu. One will be gamma mu, another will be gamma nu. What is this propagator? Let's call that propagator as d mu nu. Let's say k is the momentum of the photon. Now tell me what this k is. So this is, let's say this is the direction of k. What that is equal to from this diagram? It's simply P1 minus P1 prime. Clear? So that is same as what? P2 minus P2 prime. So that is same as what? P2 minus P2 prime. Teacher? Clear? So let's look at the Feynman amplitude. How to start with the Feynman amplitude? Start from writing from the right. Clear? Samajh? You start with this line, with this vertex, then this thing, then again from this thing, this vertex, and okay, in between what you have to put? The propagator. Samajh? This is how we write the Feynman amplitude. Now tell me, this is an external fermion line. What we write for the external fermion? Sorry, this is the outgoing fermion. What we write the outgoing fermion? U bar. What is the ingoing fermion? U. What is the outgoing fermion? U bar. What is the ingoing fermion? U. Samajh aaya? Okay. Since there is no photon line, this is only internal photon line. Okay, for that I have to put propagator. Now look here. So let's start with. So this is your U bar. Okay, let me put. This is your U bar. This is your U bar. This is your U, and this is your U. Clear? Just on that very diagram I will put it. Samajh aaya? So let's write it. So what it will be? So it will be simply U bar P. Samajh aaya? And in I will write this script. What is the spin? So U carries actually the spin variable at the bottom. Huh? Samajh aaya? So let me write it as like this way. U bar S prime. What is that? E1 prime. Clear? Got it? Then where I have to go? To the vertex. Samajh aaya? What is the vertex? IE gamma mu. Then what I have to write? U S R E1. Okay, so let me write, since I am putting S on the bottom, like this. Then I am having a propagator. Okay, so multiplied by, you are having now the propagator G mu nu K. So this is actually I times G mu nu K. Okay, K is the force momentum of the photon. Okay, then you again start with U bar, this very line. U bar, what it is? So it is R prime P2 prime. Then you are having I E gamma nu. Clear? Then you are having U. Okay, R P2. This one. So, samajh aaya? Everybody followed it? Talsa live to your asal par. So what it is? I times I. So it is minus E square. Got it? Everybody followed it? So what you are having at here? So it is U bar S prime P1 prime. Okay? Then you are having this gamma mu. Okay? Then you are having this U S P1. Okay? Then you are having this G mu nu K. I times like this thing. Okay? So then you are having, so let me write it here because I have a diagram here. So I will write it as U bar S prime E1 prime. So it is minus E square outside. Okay? So minus E square U bar S prime P1 prime. Then you are having this gamma mu U S P1. Okay? Then you are having this D mu nu K. Clear? So then you are having this U bar R prime P2 prime gamma nu. Then you are having U R. So this is the Feynman amplitude corresponding to this diagram. What is the propagator? So we will see in a moment. This propagator, if you see, this contains a gauge factor as well. And we have to show that this amplitude is independent of the gauge factor. Because gauge factor is a choice, is it? But whenever you try to calculate any kind of, physical observable, it should be independent of your choice. Huh? So, that means it should be independent of the coordinate choice. Huh? Okay. So now let's move to the second diagram. How you write the Feynman amplitude corresponding to the second diagram. Let's take the second diagram. When you say? So second diagram. So for the second diagram, let me write it as IMB. So you start with the external lines again. So these points are fixed. So this is your what? IE gamma mu, and this is your what? D mu nu K. Okay, and this is IE gamma nu. What this K is now? If this is the direction of the K, what K is now? P1 minus P2 prime. P1 minus P2 prime. That is same as what? P2 minus P1 prime. Now if you look at the formulas, it is simply what? The exchange of the momentum. Got it? Okay, so let's write now the Feynman amplitude. So IE times IE is minus E square. So that comes here. So that I will write. Now what is the first final state particle? E minus P2 prime S. Okay? So it is U bar, tell me, S prime. Okay, P2 prime. Sorry, P1 prime, like this thing is. Isha? Yes. So is there any gadbad? Yes, sir. Sorry. US. Only the momentum is exchanged. Okay. So this is S prime. This is R prime. समझ आओ? We are not exchanging this. Although you can relabel, there is no problem. But so what it is? It is U bar R prime P1 prime. Then you are having gamma. What is the factor? This line is here, huh? This is gamma nu. Gamma nu. Then what you are having? U R P2. Clear? Clear? So now you are having, what is changed? Now look here, look at this very formula. You are having P1 and P1 prime. What you are having? P2 and so this is P1 prime. Then what you are having? Propagator. So there is an I with the propagator. Give me mu. Then so you write. So U bar, okay, S prime, P2 prime. Then you are having gamma mu, gamma mu U S. Clear? समझ लो? So then you start from this line. Okay? So it is S prime. Sorry, no. This is S. This is S prime. समझ आओ? So these are the Feynman amplitudes for these two processes. Now let's check. So what is this d mu nu? We need to show. Okay, so these amplitudes are actually independent of what? Gauge parameter. Now what is our d mu nu k? Can anybody? Minus g mu nu or eta. Have we used eta here? We are using eta. Eta is the Minkowski space map. So you are having k square plus I epsilon. Then what you are having here? One divided. So it is eta mu. So one here, no one here. K mu. Is okay. So what is the factor here? So 1 minus. Isha? Is this the case? Huh? Is this the case? So this is our the Feynman propagator for the photon field, but it depends on what? The gauge parameter. Clear? So now let's take any of the terms. Okay? Now let's check with that gamma mu. Okay? So okay, so let's look at this very term. So this term contains k mu, clear? And this term contains both k mu and k mu. So let's check this term. So when I insert this, now look here what I am trying to do. Look here. When I insert that very term in this very object, so d mu nu, there will be the first term eta mu nu term and plus the other term, clear? So I am using the other term because I need to show that the other term is equal to 0. Just learn this thing. This is a very important point. So what is the other term? K mu and K mu. So let me take now this thing. So you are having this K mu. So let me take this object K mu and So let's write on what side this k mu acts. So you are having this. Okay, so you are having this very object at hand. So u bar s. Okay, forget about these spin variables. So it's something p1 prime. Then you are having this gamma mu. Okay, then you are having this usp1. So then you are having this very factor k mu. Okay, forget about this k square because it's a number. Okay, so these are the vectors. Then you are having u bar, okay, p2 prime. Then you are having u gamma. So sorry, there is a gamma nu. Then you are having u p2. So we need to check what exactly this is, whether this is equal to 0 or not. Okay, so let's check it. Okay, so let's take k nu. What will be that? K nu acting on this thing, anybody? Okay, so let's take, so this very object from here. So what that is equal to? So it will be simply u bar p2 prime k slash u p2. Can I write? What is k slash? K slash is equal to k nu gamma nu. Okay? Now tell me what is our k? K, if you remember, k is how much? Okay, one is p1 minus p1 prime, another is p2 minus p2 prime. No. p1 minus p1 prime and p2 minus. This is the direct process. This is the direct process. In the indirect process, it will be what? p1 minus p2. That's why it will be like this thing. So in the direct process, you have to take k mu. Okay? Okay, so now what it will be? So it will be something u bar p2 prime, k slash will be now, I will take p2 slash minus p2 prime slash u acting on p2. समझ आया? Everybody followed it? Okay, so now tell me what this object is. What is the Dirac equation? Dirac equation is actually p slash acting on u of p is equal to m u of p. So this is our Dirac equation. That's actually p slash minus m acting on u of p is equal to 0. समझ आया? Now tell me what this will be. p2 prime slash will act on this thing because it is the bar thing. So it will give me minus m. So this will act, okay, so it will be like this thing. p2 slash acting on u of p, it will be m. So let me write here. So it is m. This p2 prime slash will act on this thing. It will give me m. So it's like this. U of p, u bar of p. So what is that equal to? Clear? So that means this term is equal to 0. समझ आओ? Where from it comes? It comes from the gauge term. This is the term which depends on the gauge. If everybody followed it? Huh? So that means when you try to take, okay, so you can do it for this very term as well. So that means these Feynman amplitudes do not depend upon the gauge fixing parameter. Okay, so whenever you do the calculations, you just ignore the gauge part. Okay? So in that case, so what it will be? So let me write now the total amplitude. Therefore, the total Feynman amplitude is equal to, let me write that as Im. So it is Ima minus Imp. Minus comes from because there is a exchange of fermions, two fermions in the final state. So समझ आया? If they were the bosons, then you have to put what? A plus sign. Got it? Okay. So now what will be that amplitude? Anybody? So okay, so the amplitude will be these, you know, okay, with now this d mu nu I d mu nu ks minus eta mu nu by k square plus I epsilon. So you can remove I epsilon, it will be simply k square. समझ आया? समझ आया? So if we can go a little bit further, so we can put, okay, so let's go a little bit further. So let me do it this complete. Okay, so let's write that. So let me write. So it is equal to minus e square you can put out. So you are having u bar. So forget about spin for the time being. So let's forget about spin. So not that so much. Okay, only write the momentum. So it's u bar p1 prime. So then you are having this gamma mu us p1. So what is I d mu nu? So it is simply minus eta mu nu divided by k square. So let's write k square. Forget about I epsilon. Okay. So then you are having this u bar p2 prime gamma nu. Then you are having this u, okay, p2 minus the other term. Okay. So there is an e square as well. So it will be now plus e square. Minus and minus will be, that is minus e square. Minus and minus will become plus. Okay. Got it? So what you are having now? U bar p1 prime. Then you are having gamma nu u p2. What is I this thing? So it will be minus eta mu nu divided by k square. Okay. Then you are having this u bar, okay, p2 prime gamma mu. Then you are having u p1. Okay. So a little bit simplification. Then you can look at the diagrams. Okay. So again, so what this eta is doing? So eta will, so when eta will act on this gamma mu nu, nu will get contracted and mu will be replaced by at the bottom. So it will simply lower down the index. Clear? So while you are, okay, so now you are having minus e square u p1 prime gamma mu us p1. Okay. So this minus and minus will make it plus. Okay. So then you are having u bar p2 prime gamma mu, okay, u of p2. What is k square? K square is p1 minus p1 prime square. Okay, I will use p1 minus p. So this plus and that, it will be minus e square u bar p1 prime. So this is gamma nu. Okay, then you are having u of p2 u bar p2 prime gamma nu u of p1 divided by what is k square. So here I will write, if you see there is an exchange of momentum, so I will write p1 minus p2 prime whole square. This one, p1 minus or p2 minus p1 prime whole square. Clear? So this is our Feynman amplitude. Now if you look at the diagram now again, look at the diagram. So that will simplify things. So you are having this as the diagram. Clear? So now look here. So one vertex you can write up, another vertex you can write down with the same index. So that means now the vertices are contracted. Got it? So what is one vertex? Gamma mu up. Clear? Another vertex is what? Gamma mu down. So and start with where? Sorry, this is u bar. These are u. This is a u bar. You start with u bar, then this gamma mu, then this u. Okay? Then you start with this u bar, then this gamma mu and u. So in between what you will put? Simply 1 by k square. So and you have to figure out what k square is. K square is this momentum minus this momentum. So in same in the other diagram. Clear? Any question? You have followed it how to do it? Pencil it up. Okay. So now let's take the another process. Okay, so let's take the Compton scattering. Okay, so now you have seen our Feynman amplitude does not depend on the gauge parameter. This is very important fact. Okay, so now let's take the Compton scattering. What is the Compton scattering? And try to figure out what is the Feynman amplitude for the Compton scattering. What is Compton scattering? It is the scattering, elastic scattering between electron and a photon. Clear? So it is this kind of thing. So E minus ES plus gamma of AR. Gamma means what? Photon. Photon. So this R does not mean it's spin, it's the polarization. So E minus E prime S prime plus gamma. Okay. So now what are the diagrams? So in the initial state what you are having? So it's an elastic scattering. So it is simply the elastic scattering. What is the Feynman diagram? You are having an electron. For an electron, since it is again a second order process, clear? So you are having, let's say, an electron that's coming. So this is your electron, and there is what? A photon, clear? So you are having an initial photon like this thing, and then you are having in the final state what? An electron, let's say, and then a photon. So what is the mediator? So it's a Fermion propagator. So समझ आवा? Huh? Got it? Because how many photons are at hand? 2 photons. Those are here and here. How many fermions? Here and here. So what is the possible propagator between the two? It is a fermion propagator. It is since it is a second order process. So in the Hamiltonian you will be having 2 A mu's. A from one Hamiltonian, A from another Hamiltonian. Okay, so those 2 A's will give you 2 photons. And you will be having other 4 fermion fields. Psi bar psi, psi bar psi. So 2 you keep for the 2 electrons, 1 for the initial and the for final. How many are remaining? 2. So those 2 contract. So you will get this kind of propagator. Clear? समझ आवा? Okay. So let's say this is your electron. So what is this? This is a fermion propagator. So let's call it as SF. So what is the momentum corresponding to this thing? So if this is the momentum, so let's say it is your PS and this is your gamma. Okay. So can you tell me how we write the initial state photon? So this is our K. So what is the momentum here? Anybody? So it's P plus K. Because both the momenta are moving within the vertex. Okay. How we write the initial photon? What is the factor for the initial photon? So it is epsilon, the polarization vector. Clear? It is the polarization vector. Is that true? Okay. So let's write that as epsilon mu, and that carries the momentum K. So what is this very factor? So it's minus IE, the same thing, gamma mu. This will be minus IE gamma nu. The same thing, clear? So this is your external electron. So it is U P prime S prime. So this is the external. So it is epsilon star. You take nu here. So it will be something K. And okay. So समझ आवा? So these are the polarization vectors, 4 vectors. Huh? समझ आवा? What is the momentum? Sorry, it is the K prime. Huh? I have not specified in this. So you can put mu R. R will be actually the polarization state, and you can put here nu R prime. R prime will be what? So it will be like this thing. You can put nu R. Okay. You can put here nu R prime. समझ आवा? Those will specify the polarization. And what is the another possible diagram? This is one of the diagrams. Another diagram is the, okay, so you can think this process, so electron absorbing an electron in the initial state, okay, then re-emitting the same electron. This is the same thing. So scattering would be an absorption of the electron, then at this point it is releasing the same electron. So now it may also happen the electron emits, let's say an electron comes, it emits an electron, it loses some energy, clear? So that where that photon will go? So that, let's say you are an electron, it loses some energy. So that energy will come in terms of the photon. Where that will go? That will go in the final state. So that's actually the final state photon, okay? And then after some time, what will happen? So it will absorb a photon. So when it absorbs, that means it has absorbed an initial photon. It is like this kind of diagram. Okay, so you are having an electron, okay? At this very point, so it releases a photon. So then you are having this electron, so it goes and it absorbs actually photon from here. Okay? So since this wave coming from where? Initial state, a line going into the vertex means an initial state. A line moving out of the vertex is what? Final state. Got it? So this is your electron. So what is the factor here? It will be same thing, minus IE gamma mu. This will be same as minus IE gamma nu. Clear? Okay, so this is your UPS and this is, okay, U bar P prime S prime. Now tell me what this is. So it is same thing. Since it is the initial photon, we always represent by epsilon. Okay. So it will be epsilon mu, okay, r k. Samajh? So what this photon will be? So it is epsilon mu r prime k prime. Samajh? Because it is a final photon. Huh? Okay, so what this is? This is the same propagator I S F. So what is the momentum here? It will be now p minus k prime. Okay, or the same thing. This k. Okay, k minus p prime. Samajh? Rather k plus p prime. This momentum. Or sorry, p prime minus k. Sorry. Either it will be p minus k prime, this momentum minus this thing, or it will be this momentum minus this thing, p prime minus k. Samajh? Now let's write the Feynman amplitude. You followed it? Now look here. Since there is an exchange of the photon, feel it? So photons are bosons, is it? And initial and the final state photon. If you look at this diagram and that diagram, initial and the final states are exchanged for the photon only. And photon is what? A boson. So when you add the Feynman amplitudes of this very process, you add with a plus sign, not with a minus sign. Samajh? So let's call this diagram as A. Let's call this diagram as B. Now tell me what is the Feynman amplitude for this diagram? Well, listen. So the total Feynman amplitude will be sum of Feynman amplitude of A and sum of A and B. So what is our IMA? So now tell me. So this is minus IE minus IE. So it is minus E square. So that I will keep outside. So you are having E square coming. So what is the final state? You start from the final state. So U bar. So let me write it as S prime P prime this way. Then you are having the vertex gamma nu. From the vertex IE I have taken out. Okay. So then what you are having? A propagator. So you are having ISF T plus K. Then you are having this very USP. Samajh? Now then you are having actually, since there are the factors for what? Photons. So and photon variables commute with these variables. So that's why you can put it at the end. So it is something epsilon star nu r. Okay. So let me write nu r prime k prime, and then you are having epsilon mu r. Clear? Samajh? So if I define now my epsilon slash as epsilon mu gamma mu. Now look here. So you are having gamma nu here, is it? Gamma mu. So you are having a gamma mu here. So you are having gamma nu here and gamma mu here. Clear? So you can take now this epsilon star with this thing, you can make it as epsilon slash. Clear? Similarly, you can take this epsilon with this gamma mu, make what? Epsilon slash. Okay, so can I erase the diagram? Okay. So what is the Dirac? Okay, first tell me, what is the Dirac propagator? It is simply I divided by P plus, okay, what is the momentum? P plus K, okay, like this thing, slash, got it? Minus. So what is actually this propagator? Tell me, what is ISFT? So it is I divided by P slash minus M. Isha? So what is the momentum here? P slash plus K slash, so it will be like this. Now let's write. So it's I M A, so that's minus E square. So you are having U slash S prime. Okay, so let me write U slash, I will take out. So minus E square, U bar, S prime, P prime, I will take it out. So now this gamma nu, so I will put it as epsilon star prime slash. Prime means what? It contains primate coordinates. So when I take the, let's say epsilon prime, it means what? Epsilon, let's say R prime, K prime. Samajh? Got it? Okay. So then what you are having? ISF. So it is something I divided by P slash plus K slash minus M. Then you are having this gamma mu. So it will be simply epsilon slash. Then you are US. Okay. So now let's write the Feynman amplitude for the other process. Okay. So if you look at this area diagram, what is the Feynman amplitude should be? because only the photons are being exchanged. ठीक है? Okay, so everybody has written it? So let's write the second process. So Feynman amplitude for the second. So what is that? Start from the, okay, so who will tell? Manomatin. Let's write the Feynman amplitude. So minus I, that's what? Minus E square. So what remains there? Just tell me. S prime, P prime. Then you are having gamma nu. Then you are having I, S F, P minus K prime. Then you are having gamma mu. Okay. Then you are having U, P, S. So what you are having then? So one is star. So this is star. Because it is the initial photon. Huh? So it is epsilon star mu R K. Then you are having epsilon mu. Sorry. R prime. Samajh on? Is it? So now you are having gamma nu and this epsilon. Samajh on? So it will be epsilon slash. So it is minus E square. U bar P prime I will take out within S prime. So it will be something epsilon slash prime. So here prime epsilon prime is with the primed numbers. Okay. Then you are having this I S F. So it is I divided by P slash minus K prime slash minus M. This very objective. Then you are having this gamma mu and this thing. So it is epsilon star slash. Huh? So then you are having U, P. Okay? Samajh aaya? Now look at the two things. So if you look at these two processes, since these are the, two diagrams, you need to take the sum of these two. Samajh aaya? Samajh aaya? Okay. So let's take a look at these two processes, what they give. Now if I now look at the symmetry between the two. If I interchange here, so in this very diagram, in this diagram, if we interchange epsilon by epsilon star and K by minus K. Samajh aaya? You will see this amplitude is same as this amplitude. So now look here. Let's put epsilon star here. So when you put epsilon as epsilon star, what this will be? Epsilon prime. Samajh aaya? What this is? Epsilon star. What you are having? Epsilon prime, epsilon star. Now when you put K to minus K, what you will get? So I should say minus K prime. Clear? Because K and K prime, they denote the momentum of the initial and the final photon. What it means? So yes, it's a crossing symmetry. So you are interchanging, actually when you interchange the initial and the final photons in a given process, and if the amplitude remains the same, if it does not change, such symmetries are known as the crossing symmetries. Samajh aaya? So under this, look what I am changing. Look here, this diagram, if you look at the previous diagram, okay, so you are having this diagram, okay, clear? So now look here, what is the difference? Only the initial and the final photons are being interchanged. So this comes here, okay, and this comes where? Here. Samajh aaya? So what is the difference between these two diagrams? Only the crossing symmetry. Okay, so only the initial and the final states of the photons are being exchanged. Got it? And the result, okay, the sum of the total amplitude of the Compton scattering will be at second order the sum of these two. Got it? So samajh aaya? Okay. So now let's go to the another process. Okay? 3 seconds.